Dave, you have an amazing facility here. A lot is going on, and it probably takes a little bit of power to keep everything going.
Yeah, you are right, and takes a little bit of power and a lot of people to help manage that power here at the facility. We have Matt Garrison, who's an electrical engineer with the Kern County Water Agency.
What does your job exactly entail, and how much energy goes on and what you have to do at this plant?
So as the electrical engineer, I help manage the different electrical facilities we have, be it pumping, generation, and then all the incoming sources.
And what do you like most about being an electrical engineer, and what did you have to study in college to do that?
Actually, just electrical engineering. But the best part is that everything we do anymore is electrical. And you can work on anything from as small as software or little tiny chips, all the way up to giant motors and transmission systems that go for hundreds of miles.
Now, over our shoulder over here, we see an entire solar field. What exactly do you do with this?
So for these, it's actually a 1 megawatt system, meaning that it can peak at 1 megawatt of production at any given time, usually in the spring. And it's actually a single axis tracker system, so the majority of all the panels actually tilt throughout the day to follow the course of the sun, which increases the efficiency and then the energy produced from that. Over the course of 2014, we generated 1,660,000 kilowatt hours, which would be about enough to provide for 153 homes or so.
Wow, and what's the difference between the amount of energy needed versus treatment and also distribution?
So treated water actually uses considerably less. We're looking at about 900 kW at any moment to actually treat the water. To push it out to the customer though in distribution, we're looking at about 3,100 kilowatts at any given moment. So it's about 3.5 times as expensive to get water to the customer than it is to treat it.
Yeah, definitely. And speaking of the customer, like as a customer myself, I'm wondering when my power goes out at my house, what happens here at the plant when the power goes out?
Well, we have a backup plan for that. If you want to go take a look at the generators. These are our backup generation systems. So total here we have 4 megawatt of capability. It's about 4 of the solar arrays and 2 megawatts per diesel generator. And in the case that we did have a blackout or something, we disconnect ourselves from PG&E for safety reasons. And these guys spin up in about 30 seconds to a full minute, and we should be back online within a minute or less.
That's really efficient, and it's great to know that we have a good backup plan.
Well, on this edition of Do the Science, we certainly have had a fascinating flow of events to travel through. Olivia, what do you take away from all of this?
You know, I think my favorite part was just seeing the water at the initial stage and then seeing it all the way at the end and how much energy actually goes into the treatment plant.
Yeah, I absolutely agree with you. This entire process, which is extremely extensive, I think is important for people to understand and know how the water gets to their homes and how it's purified and how it's made consumable. And so just to see, like Olivia, the entire process was incredibly rewarding. So I had a lot of fun. It was great.
Indeed it was. We did have a lot of fun, and today's program was funded and sponsored by the Kern County Water Agency's Improvement District Number 4. And for all of us on this edition of Do the Science, thanks for watching.
Production funding for this program has been made possible by a grant from the Kern County Water Agency Improvement District Number 4, financed under the Safe Drinking Water, Water Quality and Supply, Flood Control, River and Coastal Protection Bond Act of 2006, Proposition 84, and administered by the California State Department of Water Resources.